Okay, we're going to do a couple of questions now with some fractions that involve uh, simplifying by factorising and then dividing through by common factors. Right, so the first one looks like this, and the question is simplify x squared plus 2x on x squared minus 4. And this is question 1 out of exercise 7J. Okay, so on face value you look at that fraction and there are no, it doesn't look as if there are any common factors in the top or the bottom. Sure, both have got an x squared in the top, but you ought to know, because I've been saying it again and again, you cannot just simply, one does not simply delete x squared from the top and the bottom because it just happens to be there. Okay, it needs to be factorised before we can do anything. So that is always the way forward with these questions. We have to factorise before we do anything with simplifying fractions. So let's factorise the top. Okay, so that's going to be, well, if we just look at the numerator there, x squared plus 2x, there is a common factor of x. So I'm going to take that x out. We'll have x plus 2 in brackets. So that's the top factorised. Then the bottom, x squared minus 4. X squared, that's a perfect square. 4, that's a perfect square. This is the difference of two squares. Okay, we know how to deal with that. X squared minus 4 becomes, I'm not going to go into the reason why, because you guys have been doing this now. You should have some practice at this. X squared minus 4 is x plus 2 times x minus 2. Now we've got the top factorised, we've got the bottom factorised. So now we can divide the top and the bottom through by common factors. And you'll see that in the top there's an x plus 2, and there's an x plus 2 in the bottom as well. And so if we divide the top and the bottom by x plus 2, that eliminates it from the top and the bottom, and we end up with a simplified expression, and it's going to look like this. X on x minus 2. And that's it. We're done simplifying. We've finished that question. Okay, second example. This is actually question 3 from the same exercise. X squared plus 2x plus 1. Now that is a quadratic. And you'll see that that middle expression, 2x, so the coefficient, the 2, is double the the 1 there. So that is a perfect square. All right, it's the a plus b all squared expression, and so we can factorise that quite easily. The bottom is the difference of two squares. X squared minus 1 is x plus 1 times x minus 1. So this is going to become, when we factorise it, it'll be x plus 1 times x plus 1 over x plus 1 times x minus 1. And once we, now that we've got it factorised, we can cancel common factors in the top and bottom. X plus 1 will go in the top and the bottom, and that leaves us with x plus 1 over x minus 1. That is as far as we can go. Don't be tempted to cancel the x's. You can't do that. Okay, that's as far as it goes. Once we've done that process of bringing out common of factorising and then dividing through by common factors, we can't take it any further. That is it. Okay, so that's our second.